Hi everyone and welcome to the learning curve. In this video I will be looking at evaluating functions, particularly evaluating composite functions and evaluating the inverse of a function. In this first problem we are given f of x equal x minus 1, g of x equal x plus 5, and we're asked to evaluate the composite function f of g of x. So to evaluate the composite function, we call this a composite function because it is a joining of two functions. In other words, you're going to substitute one function into another. And what we do when we're evaluating a composite function is to substitute the function on the right into the function on the left to replace x in the function on the left. So f of g of x will be rewritten as f of, then I'm going to write the function g of x, which is x plus 5. Here g of x is equal to x plus 5. So f of g of x would be equal to f of x plus 5. What I did here was to just replace g of x with its functional form, x plus 5. And then what we're going to do is that we're going to substitute the x plus 5, which is g of x, into the function f to replace the x in f, this x here. So therefore, the result becomes x plus 5, because we use the x plus 5 to replace this x in f of x. So it becomes x plus 5, take away this one, because the x plus 5 completely replaces this x here. So when we simplify this, we get x plus 5 minus 1 is going to be 4. So the answer is x plus 4. This is it. Let's look at this other composite function here. Here we're given f of x equals 3x plus 1, g of x equals x minus 2, and we're asked to find g of f of 2. Since we're told in this problem that we need to evaluate the function at a particular number, there are more than one ways to do this, but one of the simplest ways is to first find f of 2. So I'm going to re-express this as, so g of f of 2 means that I'm going to evaluate, I could evaluate g of f of x and then substitute 2 into the function to replace x and simplify, or I could evaluate f of 2, which is the approach that I'm going to take. I'm going to evaluate f of 2, meaning I'm going to substitute 2 to replace x in the function f, and then simplify and then substitute that answer into g. So I'm going to set this up as g of bracket, then I'm going to evaluate f of 2 by substituting 2 to replace x in f. So it becomes g of 3, and I'm going to multiply, I'm going to use this 2 here to replace x in f. So it'll be 3 multiplied by 2 plus 1. And that will give us the result for f of 2. So this becomes g of 3 multiplied by 2, which is 6, plus 1, which is 7. So what we're really going to evaluate here is g of 7, because 7 is the result of evaluating f of 2. Again, when we evaluate f of 2, we simply substitute 2 to replace the x in f. Since x is multiplied by 3, we multiply 3 by 2 to get 6, plus 1 gives us 7, and that gives us f of 2 itself. Now we're going to substitute that result for f of 2, which is 7, into g to replace the x in g. And since g of x is x minus 2, when we use 7 to replace that x, we get 7 minus 2. And the answer for that is therefore 5. So that's our answer. Now let's look at another composite function. Here we're told that f of x is equal to x squared plus 4 and g of x is equal to the square root of x. And then we're going to evaluate f of g of x. So f of g of x is equal to f of, we're rewriting this as f of g of x, which is the square root of x, right? Because we're just rewriting this by replacing g of x with its functional form, square root of x. So it is just a simple rewritten form. And then what we're going to do is that we're going to substitute the function on the right, which is the g of x, which is root x, into f to replace the x in f. So since f of x is x squared plus 4, when I use square root of x to replace x in f of x equal x squared plus 4, since the x is squared in f, then what is replacing it, which is square root of x, has to also be squared. So we'll get the square root of x all squared plus 4. Then we simplify. When we square a term that has a square root, the square root is cancelled and we're left with the term under the square root. So this would just be x plus 4. And that's our answer, x plus 4. Because the square root of x all squared just gives us x. So the square root is eliminated when we square the term. So those were 3 problems in evaluating composite functions. Now let us look at how to find the inverse of a function. So to find the inverse of a function here, f of x is equal to 2x plus 3. Now let us recognize that f of x is the same as y. Okay, f of x is always the same as y. So I'm just going to rewrite this as y equals 2x plus 3 again, because f of x is just the same as y. So I re-express this as y equals 2x plus 3. And then what we're going to do is that we're going to firstly interchange x and y. So that means that wherever x is, we're going to put y, and wherever y is, we're going to put x. So I get x equals 2y plus 3. What I've done here is that I interchange the x and the y. So wherever y is, I put x, and wherever x is, I put y. And then we're going to just solve for y. Firstly, we're going to subtract 3 from both sides since we're solving for y, which means that we're trying to make y the subject of the equation. So in trying to make y the subject of the equation, we're going to get x minus 3, because this positive 3 on the right side is going to become negative on the left-hand side of the equation by inverse operation. So x minus 3 would be equal to 2y. And then to fully transpose for y, since y is multiplied by 2, by inverse operation, we have to do the opposite of multiplication by 2, which is division by 2, to get rid of this 2 that is multiplied by y, so that we'd have y on its own. What you do to one side of an equation, you have to do to the other side of the equation as well. So we'll divide the left-hand side x minus 3 by 2 as well. 2 cancels on the left-hand side, leaving us with y equal x minus 3 all upon 2, and that is the inverse of the function. So I say, therefore, f, this is the symbol for the inverse, so we just say, therefore, f inverse x. This means the inverse of the function. F to the minus 1x means the inverse of the function. F inverse x would be equal to x minus 3 all over 2. And that is the answer. X minus 3 all over 2. And this is my illustrative lesson on evaluating composite functions as well as evaluating the inverse of a function. Much more to come. Stay tuned to the Learning Curve Academy. Remember to share, like, and subscribe. Thank you.